Hello, Sir Andrea and Sir Andres. I'm Master Vemberly from LB02 class, Research Methodology course. In this video, I'm going to present my research paper, my group research paper. I'm a member of Group 2 named Serene Group, and our research paper is titled Enhancing Movie Recommendations, Hybrid Filtering Approach, Combining Collaborative and Content-Based Filtering. So the contributors of this research paper are me, Esther Vemberly, and my partner, Eugenia Ansila. Also, the lecturers, which are Sir Andres and Sir Andre Cholanda. For the agenda of the presentation, first I'm going to talk about the introduction, then continuing to the objective, methodology, result, and conclusion. And of course, I'm going to just present the sources to make sure that I have presented all of the parts of the paper. So from the very start, which is the introduction, our research paper highlights the growing importance of recommender algorithm in various industries, which can be seen later in the sources. We have covered a lot of data sets that have been used in the recommender algorithms. But in this paper, we particularly focus on the movie dataset, movie recommendation system. And we found that while demographic filtering, collaborative filtering, and content-based filtering have been proposed as individual approaches, a single method may not provide the most accurate recommendations. To address this problem, our paper proposes a hybrid filtering approach that combines both collaborative and content-based filtering to overcome the limitations and enhance the recommendation accuracy. So by leveraging user ratings and movie datasets, the recommender system analyzes similar users' preferences and recommends popular movies while also considering the movie attributes such as the genres and it's to suggest the movies align with the user preferences. So basically, I have talked about the objective in the introduction, but to emphasize it again, our research paper is to enhance the recommendations of the movie recommender and also eliminate the problems that have rise while just using individual approaches. So we eliminated by combining the strength of two approaches, which are collaborative and content-based filtering. So here is the methodology. We have 5 parts here, which I'm going to elaborate it further in the next slides. First is data acquisition. Next is data cleaning and preprocessing. Then partitioning the data set into training and test data. Movie recommender system model design, and then model evaluation. Okay, starting from the data set acquisition, we acquired the data set from Kaggle, which is an open source website providing different kinds of data sets. And in here, we acquired the movie lens 100K dataset, which consists of 100K ratings from 943 users on 1,682 movies. It ranges the rating from 1 to 5. Each user has rated at least 20 movies, and simple demographic info of the user also have been provided, such as the genre, the age, gender, not gender, occupation, and zip. Zip is the location of the users. Then we clean the data, preprocess it by simply doing these 3 steps, which is identifying and eliminating null values, then dropping unnecessary columns, then identifying and removing duplicate values. After the data have been processed, and we have partitioned the data into training and dataset, a test dataset, 60% training data, and 40% test data. So after we have training and test data, we design the model before trying it out. So the design consists of the collaborative using SVD algorithm, singular value decomposition, which is to analyze the user behavior based on the ratings. Then the content-based model, which is KNN, gathers the rating from the users, from the similarities genres between the movie items, and from the rating gathered, which is the neighboring items. Then we order these neighbors and calculate the average similarity score weighted by the user ratings. Then after we have both approaches, we design the hybrid, which is combining those two approaches with 50-50 way. So as you can see here, these are the results of our model evaluation after trying it out on the training and testing dataset. So here we have two different evaluation metrics, which are RMSE and FCP. RMSE or root mean squared error. Lower values in here means better accuracy, while in FCP, higher values mean better accuracy. FCP stands for fractions of concordant pairs. So first, for the content-based filtering models, or it represented by the blue color in the graph, the training RMSE suggests that it fits the data quite well, 0.95. But the test RMSE suggests that it has a higher error level, which is 1.14 here. Could be a result from the limitation in the content-based filtering, such as it relies on the movie attributes and the lack of user-item interactions. And for the FCP values, indicates that the model only captures moderate concordance with user preferences. Then for the collaborative filtering model, which is represented by the orange color here, we can see that based on the RMSE value, the test data shows a little slightly higher error, which could indicate a slight overfitting from, as you can see here, 0.9 and 0.94 in the testing. So only differs like 0.04. Then for the FCP value, the model also maintains a relatively consistent ranking accuracy, here 0.73 and 0.7. And the model indicates a higher level of concordance than the CB model. Then for the hybrid filtering model, the training and testing RMSE suggests a low degree of error, lower than the training and testing of the content-based and collaborative. Only for the collaborative testing, it has a slightly higher, but I'm going to discuss it in the conclusion. And for the FCP values by model, we can see that it surpasses both CF and CBF2, which shows an accurate prediction of performance. So what's the conclusion? In this study, we investigate the performance of three recommender systems based on their training and testing RMSE and FCP values. Although the test RMSE and the FCP values of the hybrid model fall between collaborative and content-based model, it nonetheless accurately predicted the movie recommendation for unseen data. So, combining collaborative and content-based filtering shows that the hybrid model offers a more comprehensive approach to identifying user preferences and providing personalized recommendations. So that's all from me. Thank you for listening. And as I have mentioned before, here are the literature sources that we have discussed in the introduction and also the literature part of our paper. You can read it further in the paper. So once again, thank you for listening and have a good day.